Today we also discuss one important topics related to inner product and norm. We also discuss norm. Okay. Today we discuss norm, also known about that norm. So now we're going to discuss we known about that. Okay, the length of x, the length of x a b c in R cube. Okay, is given by what? Is given by this one, square root of a square plus b square plus c square. Okay, then this one equal to what? This one equal to here inner product of x, square root of inner product of x. Okay, now we write here definition. Okay, now we write here definition. Then definition of norm, let V be an inner product space. Let V be an inner product space. Okay, V be an inner product space, and for x belongs to V, for x belongs to V, we define the norm. We define the norm or length of x, norm or length of x by norm of x equal to square root of inner product of x. Okay, this one. Then what happened is here we write it now. This one with the norm or length of x. Okay, now we write it one example related to that. Okay, we write it here, let v equal to fn. Okay, and then if x equal to a1 a2 dot an. Okay, and then norm of x equal to what? Here norm of a1 a2 dot an. Okay, here equal to what? Equal to I equal to 1 to n. Okay, mod of ai square whole to the power half. Okay, this is the Euclidean definition of length. Okay, is the Euclidean length. Euclidean length. Okay, or Euclidean definition of length. Then we also discuss another theorem related to that topics. We now erase that portion and going to further discussion of that. Okay, so this one is norm and we give one example. Now we erase that portion and going to further discussion of that. Okay, we write here theorem. What? Let V be an inner product space over F. Let V be an inner product space over F. Okay, then for all xy belongs to V, then for all xy belongs to V. Okay, and C belongs to F, and C belongs to F, the following statements are true. The following statements are true. Statements are true. Okay, what is here? First we write norm of cx equal to mod of c norm of x. Okay, and number two, we write here norm of x equal to 0. Okay, if and only if x equal to 0, if and only if x equal to 0. Understood? And then what happened in again in any case the norm of x greater than 0. Okay, or greater than equal to 0. And again we write c what or c Schwarz, Cauchy Schwarz inequality. Okay, this gives what? This gives here x y inner product mod of this inner product x y less than equal to norm of x norm of y. Okay, and t what happened? Triangle inequality. Okay, triangle inequality. This one equal to what? Mod norm of x y equal to norm of x plus norm of y. Okay, less than equal to this one. So we also discuss this one, this proof easily. We're also going to step by step. Okay, that means first we discuss first one and then next one. We're also going to discussion of that. So we erase our portion and going to further discussion of that. Okay. Then here we write that norm of cx equal to what? Norm of cx equal to square root of here cx. Okay, cx. Understood? Then what happened? Then we also write here in this way cx and cx. Okay. Then again we write c conjugate this. Again we write here norm mod of c square x. Again we write mod of c here x inner product of x. Again we write mod of c here norm of x. Okay, so not a problem at all. This one is too easily we do it. Okay, for any c belongs to f. Okay, so now we erase that portion and going to further discussion of that. Now we also discuss this one, that means b here norm of x equal to 0 if and only if x equal to 0. That means this implies, okay, this implies what? This implies this one be 0. This implies this one be 0. This implies this one. Okay, we write it in this way equal to 0 0, or another way, that means this one then x equal to 0. Otherwise we write it this way. Okay, here x0 plus 0x equal to 0 0. Okay, or equal to 0. Then x0 equal to minus 0x equal to x0. Okay, here 0x, then x equal to 0. In this way we also done it. And again if x equal to 0, then obviously norm of x equal to square root of inner product of x equal to inner product of 0 0 equal to 0. Understood? Not a problem at all. So if and only if this one happen. Okay, now we're going to discuss Cauchy Schwarz inequality. We erase that portion and we're going to further discussion of that. Okay, now we write here Cauchy Schwarz inequality. Okay, Cauchy Schwarz inequality. Understood? We have to prove this one. mm, inner product of x y mod less than equal to norm of x norm of y. Okay, then what we do here? Okay, okay, now we also discuss here if y equal to 0. If y equal to 0, then inner product of x 0 equal to 0. Immediate this one happen. Okay, that means obviously this one happen. Obviously done. Okay, if y not equal to 0, then what happen? If y not equal to 0, then for any c belongs to f, okay, we have what? We have here 0 less than equal to norm of x minus cy square. Okay, this one happened because any norm greater than equal to 0. So this one is happened. So we write it in this way. This one equal to x different cy, x different cy equal to what? X here, cyx. Okay, here x cy and plus yy. Okay, equal to what? Equal to norm of x square difference cyx. Okay, here difference c conjugate xy, here norm of y square. Then what happened? We put c. We put c equal to what? Inner product of x y by inner product of y y. Okay. Then what happened? Then we get, we put this one. Then we get. Okay. Now we erase our portion and going to further discussion of that. Then what we get? We get here, that means norm of x square difference c, that means x y y y, here y x. Okay, and here c conjugate, that means x y conjugate y y y conjugate. Okay, and here x y. Okay, plus norm of y square. Obviously this one greater than equal to 0. Okay, then what happened? This implies that. This implies what? We write it here. Okay, 0 less than equal to norm of x square here, xy here, xy conjugate y norm of y square, and here xy and xy conjugate y norm of y square. Okay, here norm of y square. Sorry, we do some mistake here. Okay, we do some mistake here. That means here we also not see that. Here obviously plus c c y y. Okay, then here obviously mod c square. Then we also do something mistake here. That means here obviously we put c square. Then what we get? We get here, that means x y square mod of this one by y norm of y square. Okay, norm of y to the power 4. Okay, and here obviously this one, then this one cancel, and we write here x y square by norm of y square. Understood? Then what happened? Then this one obviously cancel. This one obviously done. We write it in this way: 0 less than equal to norm of x square here, x y square by norm y square. Okay, minus this one is 2, and here 1, then this one is 1. Okay, understood? Then this gives what? That means we do some mistake. Don't think about that, but easily you accept it because this one happened. Okay. Not a problem at all. Now we discuss this topics. Okay. So this one here, this one x y square y or norm y square less than equal to norm x square. This implies that norm of xy inner product of xy mod square less than equal to norm of x square norm of y square. This implies that what inner product of xy less than equal to norm of x norm of y. Okay, done. Not a problem at all. Prove this one. Okay, some mistake is happened first. That means I'll not see about that here. Will obviously cy and cy. Okay, plus in this way. Then this one c conjugate y. Then this one will not see first. Okay, not c square and not y square. Okay, this one will not see first. This one mistake we done, but obviously we correct this one by further step and do it easily and get this result. Okay, not a problem at all. This one is too easily we done it. So now we erase that portion and going to further discussion of that. Now we also prove B. Okay, we have what? We have norm of x plus y square equal to what? Equal to inner product of x plus y equal to what? X plus yx plus xy plus yy inner product. Okay, then this one equal to norm x square here xy conjugate and here xy here norm of y square. Then this one equal to norm of x square plus this one equal to 2 sorry real of this one 2. Okay, understood? Not a problem at all. I think this one is too easy. Okay, plus norm of y square. And then what happened? This one less than equal to norm of x square plus here 2xy inner product of xy plus norm of y square. Okay, mod of inner product of xy obviously real of inner product of xy is less equal to this one. So this one happened. So what we write here? We use last um, last inequality. Okay, that means Cauchy Schwarz inequality was used here. Then what we get? We get this one. Okay, then this one equal to what? This one equal to this one. Okay, then what happened? Then we get this one norm of x plus y less than equal to norm of x plus norm of y. Understood? Not a problem at all. This one is too easily we done it. So we'll also give one another example. Okay, we're going to discussion another example now. When I erase that portion, I'm going to further discussion of that. So we write here example. Okay, we write here example. What happened for fn? For fn. Okay, for fn, the standard inner product. Okay, to obtain the following well-known inequalities. Okay, obviously we write it in this way: I equal to 1 to n ai bi. Okay, conjugate mod of this less than equal to summation I equal to 1 to n ai square mod of this ai square whole to the power half, and here summation I equal to 1 to n mod of bi square whole to the power half. Okay, then what happened? And obviously we also write it in this way. Okay, that means what happened. And this one, that means summation I equal to 1 to n ai and bi mod of this one. Okay, this square whole to the power half less than equal to what? Less than equal to I equal to 1 to n ai square whole to the power half plus here I equal to 1 to n mod of bi square whole to the power half. Okay, done. We also do it too easily. Okay, so this one is so simple. We also do it. Well, not inequality standard. We use this standard in our product. Okay, now we're also going to discussion another one. Okay, yeah, that means for x y in r cube, for x y in r cube. Okay, for r square anywhere. Then what happened? Then we write it in this way: inner product of x y equal to here norm of x norm of y cos theta. Okay, where theta equal to theta equal to 0 less than equal to theta less than equal to phi. Okay, denotes the angle between, denotes the angle between, denotes the angle between x and y. Okay, then what happened? Then obviously non-zero vectors x y are perpendicular. Then what? Obviously we write it in this way: x perpendicular y if and only if what happened, cos theta equal to 0, and if and only if what happened, inner product of x y equal to 0. Okay, this one, this one, and this one happen or not? I think this one is done. Okay, now we're going to discussion another theorem. Sorry, definition. Okay, we erase that portion and going to discussion another definition. Now we write it here. Okay, one definition. Definition here. Let V be an inner product space. Let V be an inner product space. Okay, let V be an inner product space, and here vectors x and y in P, vectors x and y in P, okay, are orthogonal or perpendicular, are orthogonal or perpendicular if what happen, if this one inner product of x y equal to 0. Okay, now we write it here in this way. Okay, a subset is of V is orthogonal, a subset is of V is orthogonal. Okay, when if any two distinct vectors in S are orthogonal, if any two distinct vector, any two distinct vectors, okay, vectors in S are orthogonal, in S are orthogonal. Then what happened? We talk about that one set or subset of V is orthogonal. Okay, that means any two vector, distinct vectors are orthogonal. Then what happened? Next we're going to discussion a vector x in V, a vector x in V. Okay, is a unit vector. Is a unit vector if inner norm of x equal to 1. Okay, now we write here a subset, okay, s of v, s of v is orthonormal, is orthonormal, okay, is orthonormal if s is orthogonal, if s is orthogonal, if s is orthogonal and consists entirely of unit vectors and consists entirely of unit vectors. Okay, not a problem at all. Understood? That means a subset is of V is orthonormal. If S is orthogonal, orthogonal when this any two distinct vectors are orthogonal and consist entirely of unit vector, then all are obviously unit vector. Then we call about this subset is orthonormal subset. Understood? Not a problem at all. This one is too easy, I think. Now we're going to discussion one important example. Okay, we erase that portion and going to further discussion of that. Now we write here one topics. Okay, if is equal to v1 v2 dot. Okay, then s is orthonormal, then s is orthonormal. Okay, orthonormal when, that means if and only if, okay, vi vj must be 0, inner product of this one 0, and obviously vi norm equal to 1. Understood or not? I think this one is too easy. Okay, if we write it in this better way, okay, that means these two ones happen, we write it in this way, vi vj equal to del ij. Okay, that means del I equal to 1, vi equal to 1 and vi vj equal to 0. Okay, this one is too easy. Too easily we denote this one, and this one we know about that. Del ij denotes the conical delta, the conical delta. Okay, understood? Not a problem at all. Now we also write another portion was market star, and now we also write another portion here. This one is, that means if x is any non-zero vector, if x is any non-zero vector, okay, then what happens? Then we talk about that, then 1 by norm x x, okay, this one is a unit vector, is a unit vector. Understood? Not a problem at all. This one is too easily to do it. Okay, now we're also going to discuss one example. Okay, one example, but we talk about another one. The process of multiplying a non-zero vector by reciprocal of its length is called normalizing. Okay, we write it in this way. Of the process of multiplying, okay, multiplying a non-zero vector, okay, by the reciprocal of its length, okay, is called normalizing. Okay, now we erase that portion and going to further discussion on example. Okay, here we write example. Then what happened in f3? What happened is here 1 1 0, 1 minus 1 1 and minus 1 1 2. Okay, is an orthogonal set of non-zero vectors. Is an orthogonal set of non-zero vectors. Okay, but it is not orthonormal. How this one happened? Then we talk about that. This one is 0 1 1 0. Okay, up here we write in this way 1 minus 1 1. Okay, this one is becomes 0. Again we write 1 1 0 and 1 minus 1 1 2 0. Okay, again we write 1 minus 1 1 and here minus 1 1 2. Obviously 0. Okay, then we also talk about that they are a orthogonal set of non-zero vectors. But why we write this one? This one is not orthonormal. Why? Because we see about that 1 1 0 and 1 1 0. This one equal to what? This one equal to 2. Okay, that means square root of 2 is none. Okay, that means none of 1 1 0 equal to square root of this, so not equal to 1, so this one happens. Understood? Not a problem at all. Now we're going to discussion if we normalize the vectors in this set, then we erase that portion and we discuss about that. That means if we normalize the vectors, then what happened? Okay, if we normalize the vectors, okay, then what happened? Then obviously 1 1 0 1 by root 2, here 1 by root 3 1 minus 1 1. Okay, and here 1 by root 5, okay, root 6 1 minus 1 1, this one. Okay, if we normalize this, then we get this one is that means the orthonormal set will obtain a orthonormal obtain an orthonormal, okay, obtain an orthonormal set. Understood? Not a problem at all. So now we're going to discuss another example related to that topic. Okay, we erase that portion and going to discuss another example. Here we write example. The inner product space H, okay, that means an important orthonormal subset is of H. Okay, we discuss in this way. We know about that this, that means this H, okay. Today we also just, that means we also discuss in this way for any integer z, okay, for any integer a, any integer not positive integer, if n t equal to what, e to the power I n, okay, and for 0 less than equal to t less than equal to 2y, okay, then what happened, then is equal to, here if n such that n belongs to z, okay, n belongs to z if n, then what happened, okay, then what happened is here, then S is a subset of H, okay. Then we talk about that here if him and if he equal to what, equal to here 1 by 2 pi, okay, and 0 to 2 pi e to the power I m t and e to the power I n t conjugate t, okay, this one equal to 1 by 2 pi as 0 to 2 pi e to the power I m t e to the power minus I n t dt, okay, then this one equal to 1 by 2 pi, okay, 0 to 2 pi here e to the power I m minus n t dt, okay, then what happened here 1 by 2 pi m minus n, okay, e to the power I m minus n t 0 to 2 pi, okay, then what happened, then this one equal to 0, okay, not a problem at all, this one equal to 0. So in this way we also discuss those ones, okay. For m not equal to n, this one happen, okay. So that means what we get, for m not equal to n, this one happen, okay. And again we also see that if n here if n, then what happen, if n, then here n, here n, and here n, then this one is, that means not needed is here, and this one is, that means we erase that portion and going to further discussion of that, okay. That means 1 by 2 pi 0 to 2 pi dt, okay, then 1, this one, okay, then what happened, here we write if m if n equal to delta mn, okay. So in this way we also see that this one, this inner product space, that means this is what happened is be a orthonormal subset, okay. This is be a, but this is be a orthonormal subset, okay, of H, okay. H equal to what, that means H equal to the inner product space defined on defined on some integration. Okay, we also discussed in previous class this one. Okay, C01 is the space H. In C01 is the space H of continuous complete valued functions on the interval 0 1. Okay, that means we write it in this way: the space here H of all continuous complex valued functions. Okay, then what we write? Then is B orthonormal orthonormal subset of H. Okay, where H is what? H is the space of what? Space of continuous complete valued functions. Continuous complex valued function. Continuous complete valued functions defined on 0 1, defined on 0 to 5. Okay, with interval with this, that means inner product equal to what? Inner product of, in this way we define inner product of, we erase that portion, then we write inner product of fg equal to 1 by 2 pi integration 0 to 2 pi ft gt conjugate dt. Understood this one? So in this way we also discuss too easily this one. So today we stop here. If you get this type of video, please subscribe my channel. If you want to give like, please click on like options. If you have any question, comment, suggestions, write it in comment box. I think all are understand these portions. If you have any problem, please write it in comment box. And I think all are obviously subscribe my channel and see this video regularly. So today I stop here. Thank you.